Hello, hello. Today we shall be developing a regression model, and here we have we have an Excel CSV format file in desktop, and I shall import the data file from desktop and run the regression model. Okay, the data file name is cells. Okay, now I write the command. To import cells file into our software, right? Okay, so here I am typing the command. First I type cells, the file name that I typed. Then I type this thing. Then I type read, and the file is CSV format. Then I write file dot choose, then this one, then comma, then header equal to true, right? So cells read CSV file choose header true. Then I press enter. Okay. Then I press enter. Okay. Now here I go to desktop. So I select I select it, and here you can see here I can see the CSV file. You can see cells file right under desktop. So I select it. Okay. Then I write again cells, the file name. So here you can see my file is here. Cells price of the house and the size of the house. So there are three variables: sales amount of the house, price, not house, sorry, this one is the computer, and this one is the size, and this one is the number of cells, and the price of the computer and the size of the computer, right? Something like this. Okay, and here cells is the dependent variable, and price and the size are the independent variable. Okay, now what I do, I can run the model. So how to make it? What I do, I write the command model1, right? So suppose the file, the model name is model1, then I write lm. Okay, then I write, so first is our dependent variable, that is cells, then this one, then my another variable price plus size, and price and size are the independent variable. Then I put comma, then I press data, then our file name is cells, right? Okay, then I press enter, then I write summary, then model1, right? The name of the model is model1. Okay, so I'm set, I'm ready. Then I press enter. You can see the model has come up. Residuals, coefficient, price and the size are two variable, and these two variable are the independent variable and the cells are the dependent variable. Okay, here what I can see. Okay, so the first question is that this is the price and this is the coefficient. You can see this is price, right? So what about this one? So this one is the coefficient of price. And what about this one? This one is the standard error, and this one is the t value, and this one is the p value, probability value. Okay, and also here in case of size, 10.92 is a coefficient and 5.29 is the standard error and 2.064 is the t value and 0.1079 is the probability value or p value, right? So here you can see probability value or p value. Okay, now the question is that how to get this 2.064. Okay, actually 2.064 I can get by 10.925 divided by 5.298. You can get 2.064. And what about this one? Minus 8.349, that is t value. How to get it? Also I can get it coefficient, that is minus 154.305 divided by 18.48. I can get minus 8.349. And the first one is the constant or intercept of the model, and this is the coefficient, this is the standard error, this is the t value and the p value. And here this divided by this, I can get t value, that is 10.912, and this one is the corresponding probability. Okay, now my question is, out of two independent variables such as price and size, right, which one is significant to explain our dependent variable which is cells, right? Okay, now what is the guideline? The guideline is that if the probability or p value is less than 5%, then that particular variable become significant, right? But if the p value is more than 5%, then that particular variable is not significant. So that is the guideline all the time. Okay, so first I talk about our first variable, that is price, right? So price. So here, how much is the probability value or p value? The price p value is here, right? It is, how much is the p value? 0.00113, right? Meaning that it is becoming 0.113%, right? 0.113%, and 0.113% is less than 5%, meaning that price is a significant variable to explain our dependent variable, which is sales. And also here you can see price, the coefficient is negative, meaning that when the price goes up, sales goes down, and when the price goes down, sales goes up. So because the coefficient sign is negative here, and that actually happen in the reality. Normally what happens? When the price goes up, sales goes down, price goes down, sales goes up. And this one is also the same result, because the coefficient is negative. So we are happy about this model because the sign is negative, and that is following our expectation. Okay, then what about the second variable, size, and what about the p value of the second variable? Size, the p value is coming up 0.10791, meaning that 10.791%, right? And 10.791% is more than 5%, meaning that size is not a dependent size is not a variable to explain our dependent variable, which is sales, because size is not a significant variable, because p value is 10.791%, and that is more than 5%. So size is not a significant variable to explain our cells. Okay, and then we talk about value of r square. Here we have the you can see there is one more thing that is also important. Multiple r square value, right? Here is how much. That means I can call it r squared value. In other words, r squared value. R squared value is how much here? Is 0.9495, meaning that 94.95%. What does it mean, right? What does mean by 94.95%? It means that 94.95% fluctuation in the dependent variable, right, which is sales, right, which is sales, can be explained by two independent variables such as price and size jointly, right? It means like that, right? That means 94.95% variation in cells can be captured by two variables such as price and size jointly, meaning that data is nicely fitted, right? Data is nicely fitted. So that means this model is nicely fitted, right? Because normally we say, what is the guideline? If the R square value, is more than 60%, right? Then we normally say that the model is nicely fitted, right? And here the value of R squared is 94.955%. That means very nicely fitted. So we are happy about this particular model. Okay. Then we talk about F statistics. You can see F statistics and the corresponding probability value, right? You can see here F statistics and corresponding p value or probability value. And here you can see the F statistics, here is the how much is the probability value. The probability value actually here of the F statistics, probability value is 0.002553, meaning that 0.2553%, right? Meaning that F statistics is significant. Meaning that these two variables such as price and size, right? These two variables are significant jointly to explain our dependent variable, which is cells. And we are also happy about it because price and size, these two variables are jointly significant to explain our dependent variable, which is cells, right? Because p value is less than 5%. That is why it has been significant. So this model is very good because because the price is significant and R squared. Now here what is happening? Out of two variable, at least one variable is significant. So out of two, 50% of the variable is significant. So we are happy about the model because at least 50% out of two, one is significant, right? So what is the guideline? The guideline is if most of the variables are significant, the model is a good model. But here out of two variables, at least one is significant. So we are happy about the model, and also the value of R square is very high, and also F statistics is significant because p-value is less than 5%. Okay, so this model is very good. We are happy about these models and so on. And what does mean by residuals, right? Right. So these are the residuals, right? These are the there are six residuals. You can see there are six residuals, right? 1 2 3 4 5 6. Why? Because sorry, there are not six, there are six residuals are here, not six, seven. You can see one more here. There are seven residual. Why? Because our sample size is also 7, meaning that every sample should have one residual. So here we have our sample is 7, so residual is also 7. You can see 7 residual. The question is that what does mean by residual? Residual means actually it means actual cells, right? Actual cells variable minus estimated cells variable, and that is called residual. Meaning that also, okay, first talk about this one, minus 4.74579. So actually this one means, so this is the actual cells 12030 minus estimated cells. Then I can get this minus 474.5479. And what about this one? What about this one? Suppose I take this one, residual number 3 minus 219.46. So you come here, number 3. So here actual cells minus estimated cells, I can get this value, which is number 3 residual, right? So that is the whole thing, it is here. Okay, thank you very much for staying with me for a while.